Hello, this is Tariq Elwan presenting lecture number 6 of the SBM4104 IT Infrastructure Unit. What we will cover today, the second function of the network layer, which is routing. If you still remember from last lecture, we had covered the first function, which is the logical IP addressing. We went over the IP address version 4. We have done some exercise of subnetting, how to do subnet, how many network in topology, and so on. Today we will cover how the routing done. Routing means sending packets or frame from one router to another router, or in general from source to destination. So what happens exactly when you send the packet from one side to another side? What you see over here, A, B, C, D, E, F, G, is actually representing a node, which means that can be a device, as you can see, or in our case here we're talking about actual router. So if you go try to understand when you send a packet, for example, from your computer into Facebook, for example, what's happening exactly? Usually the packet goes from your computer to outside to the network card, then goes to the router, which is if you are a router at home, sure, you got one, or if you at work or at business or whatever it is, it gonna goes to the gateway, which we covered last week, the router which work linked to the ISP provider. Inside the ISP provider, we have plenty of router connected within a topology. Let me show you just only an example. Something like that. You have plenty of routers linked together. Now I have thousands of routers running within, for example, Telstra. How my packet take a direction within that and goes to the Facebook. Here it is. The routing done in two different ways, either static routing or dynamic routing. What's the difference between both of them? Very basic. Static routing, usually I tell the router goes from that direction. Why is that? Because the other way around is dynamic routing. Dynamic routing, you leave that decision to the router itself to choose the best path and the shortest path as well. So how the router does the calculation? We have two main algorithms used, the two famous ones within routers, and those one does the calculations, and based on some math calculation, which we will cover later on in today's lecture, the router take a decision to move which direction I'm gonna take, A or B, and from here, if I want to go from here, take it to EF or EB, and so on. So if you left it as a dynamic routing, which is, by the way, the majority of the routing around the world done dynamically, leave it for the router up to today. Static routing, we usually use that in specific circumstances, which is limited. So over here, can I configure the router? For example, instead of, for example, if I want to send the packet to G, we have multi-direction the packet can goes to. For example, the packet can goes this way, that way, that way. Yes, but actually it can take this way, then goes that way, then here, then here. That's true, by the way. Or it can goes that way, this way, and that way, then here. Or it can come over here, over here, over here, over here. Which one will take? It depends on the algorithm inside the calculation inside here, and we will go over that shortly. So you leave it for the router, yes, to decide it and do the calculation. That router do the calculation, that router does calculation, and they talk to each other. So, and this one talk to this one, and he knows that, okay, the best option is to take the direction through here, 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 and forget about all those ones. Okay, what about if I want force the router to take specific direction? For example, if I want force that router to take that direction, for example, can I do that? Yes, we can actually do that, and we call that static routing. The difference between static routing and dynamic routing: static routing, we configure that actually manually, and we specify the direction for the packets or the frames, and we know the direction and the circuits. When it comes to the dynamic routing, we don't. You leave it to the router, and the router can send your data in through different direction. How that works? If you use the dynamic routing, we use algorithm, and that algorithm usually try to calculate the best routing or the best path. How to does done that? Through things called metrics and cost. What is metrics and cost? For it has involved some calculation and divisions. However, for you to understand that, it's involved with actual distance and the number of hops, for example, or hops means routers, latency, bandwidth, the error rate, the loss rate. It involves many actual factors. The algorithm will run those factors, which is distance, latency, bandwidth, error rate, loss rate, and finally it will calculate what we call it cost or metrics. It will calculate that, and then it will pick the lowest one. Okay, inside each router we have what we call it routing information based, or the routing table in short, if you want to take it in short. What's in the routing table? Usually the interface, the network, what is network linked to. For example, router number 1, what it has. It has, for example, this network 10, 10, 51, whatever the X is. Which interface is that? That's interface number 1. There is another factor is missing here in the RIP. We will show you that later on. This one, for example, the network 52, that 52, which interface? Interface 2. That one, for example, 10, 1, 0, whatever, that's interface 0, and so on, and so on, and so on. If you come, for example, to router number 2. What's in the router number 2 over here? The network 20, that's interface number 2. The network, let's go for network, the full network, 43 number 3, interface 3. And sure, all our addresses send it to 0, which means that send it over here outside. Okay, but how that work in a better version? This one I believe that it's much better to understand. What's inside exactly the routing table? Something like that. Inside the router number A, for example, what I will have? I will have information about the interface, the network I have. This is the network, this is the interface, and this is the number of hops. What is the number of hops? The number of routers. So what is the distance between this network? How many routers between that network and me as an A? For example, this is 10.1.0.0. What is the interface I take to go to that network? You take the interface E0. Okay, how many router or hops between me as an A router and that interface? As you can see here, nothing, because actually it link to A directly. That's why we have 0 hops or 0 number of routers. What about number .2? For example, as you can see over here, 10.2 as well link to me, so the number of hops is 0. Which interface I can take to go to 10.2? That's S0, as you can see here, which is this one. That's true as well. Okay, so you telling me that if I want to go to 10.1, I'll take the E0, and that's 0 hops between me and him. Yes. And if I want to reach 10.2, I'll take S0, and there is no hops between A and that network. Yes, because that's directly connected. Let's move to the other ones, the other router. So now I'm here inside A. Here it is. I want to reach 10.3, and I'm here. I want to send my data into 10.3. Where I can send my data? S0. That's correct, by the way. I have to send my data to read through that direction, which is this, S0. How many hops between me and 10.3, which is this one? So that's why we have here 1 hop or 1 router. Okay, what about if I want to reach 10.4? If I want to send the data from me to 10.4, where I'm gonna send it to? S0 as well. Yes, any data or want to go here, I have to send it to that interface. Okay, how many hops between me and 10.4? As you can see here, 1 and 2. Here it is. Is that the same concept here and here and here? Yes. Let me show you. Over here, for example, I have 2 interfaces, S0 and S1. If you want to reach 10.2, send it to S0, and there is no hops between, because that's directly connected, that's directly connected. As you can see here, 10.2, 10.3, this is 10.2, this is 10.3, directly connected, which means that 0 and 0 hops between. That's S1, S2, S1, I'm sorry, S0, S1, that's correct. Now I'm here and I want reach 10.1. Okay, if I want to send the data from here to 10.1, where it gonna take? It has to take that direction, which is S0. Is that correct? If I want to reach 10.1, which is here. Is that correct? Yes, that's correct. How many hops between me and 10 dot, which is this one. I have one hub between. Okay, so if I want to reach 10.4, as you can see here, the same concept. I have one. If you want to send the data, you have to send it through S1, yes, and then you have one router here in the middle. The same concept over here exactly apply. The same idea. The only difference here, that interface, there is no more routers here. No more routers. So that interface is down, for example. So we put it as down. That's how what you can see in the routing table. Each router has a routing table inside. And it's built, by the way, automatically, dynamically. And for example, if that interface has been cancelled, you will see that interface, all that router will talk to this one will talk to that, and they will update each other. And you will see team 4 has disappeared from here, team 4 has disappeared from here, team 4 has disappeared from here. That's how it is. That's mostly the basic concept of that. If you want to do routing, we have two types of routing. In terms of routing itself, we have either static or dynamic. That's in terms of router itself. As a management, we have two types of routing as well, but in terms of management. What is that exactly? Either centralized routing or distributed routing or decentralized. What do you mean by that? Centralized or decentralized? The decentralized, the one I just explained to you a minute ago. Each router, the decentralized, you have router, connect to another router, connect to another router, connect to another router, like this. Which direction that packet will go, that router will decide it. This router will decide it, either here or here. Based on what? As I told you, based on the metrics, which is involved with bandwidth, latency, error rate, delay, whatever, many things, many options. Okay. What about the centralized one? The centralized one, this is not actually new. It's been in the market for a few years. Sorry. It's been for the market for a few years, and that's used mostly by either jumbo corporate or ISP providers. What is that exactly, the centralized? So we have plenty of routers, as you can see over here. I want to send the data from here to here. Okay. If we use the distributed or decentralized, I'm gonna send the packet here and it pass here. This router will do some algorithm, then decide which direction it take and send it here. The same thing will done here, like that. No. In centralized routing, we actually turn the router to work as similar to switch. Similar, but not actually switch. What do you mean by that? The router will not do any calculation. The router will not do any algorithm. The router will not do anything except receiving instructions from a centralized routing control. A unit sitting at the top here, it has a view of all those routers and all those IPs and all those directions, and that's the one which make all the decisions. So it has an overview of everything or all the router linked to. So, and that one run the calculation and run the math and run the algorithm, then decided which direction it will take, and your, as a router, the router job For example, router 1 receive an instruction. You will receive a frame or packet in interface fast 00. Yes, send that one from the interface G00. Yes, yes. Why is that? Because usually the router has multi interfaces like this. Usually. So which direction it's gonna take? You will receive the direction from the central unit, or the router will receive the instructions where it exactly to send it through from the routing control unit. So it back come to you over here, send it here, and over here the same thing. Usually the router has multi interfaces. Which network will take? You will receive an information, send it here, send it here, send it here. What is that? Is that means that the router will do any calculation? No. Any path finding, which best path, whatever, is not. We turn that control unit, turn the routers into some kind of switching devices. Is not actual switch, but actually it turned into in term of functionality, it turned into a switch functions device. So you receive the order from here and you do whatever that control unit tell you. So the centralized one, you have a centralized unit at the top, has an overview of all the devices running, and it sends instructions, control instruction to the devices, which is the router, to pass the packet from one direction to another direction. What does that mean? The router itself doesn't need to do any algorithm running or math or calculation or find any type of metrics. The type of decentralized routing, still static and dynamic. The same concept, the same thing. What is the difference between both of them? The dynamic, it can be leave for the router to update itself. For example, you have here, I want to send the data from here to here. Which direction I will take? That way or that way? And when it come here, exactly, it's gonna go from here to here, or it gonna goes from here to here. So each router will have its own table, and that one has its own table as well. They talk to each other, exchanging data once a while, which we will cover that either 30 seconds or when anything change in the topology. So the dynamic routing usually based on each router has a table, and that table can be updated dynamically. They talk to each other. For example, if that interface went down, you will see that right away it has been changed automatically. If the link between here to here change, for example, you change the cable from RJ45 to fiber optic, that one will be updated automatically right away. The static routing is not. We configure that in the same basic concept. Instead of leave that to be updated dynamically, no. We configure that router table to have static only, static interfaces, static network, static hubs. That's how it is. Yes, we configure that, so we force the packet to take that direction, for example. That's how it is. Yes. And what about this one? Forget about this ones. So any packet goes from that PC has to take that direction. What about that direction? Has to be forgotten totally. And that's the static routing. Dynamic routing algorithm. The static routing, it configured manually, and there is no problem with that. Just a few commands in the CLI. The dynamic routing is the most important one, and actually enthusiastic as well. Something you really, when you work on it, you will like it. There are two main, let's say, routing methodology. Let's say two type of routing methodology. Each one use different type of algorithm. However, both algorithm, the job for both algorithm to find the shortest and best path for you. One of them, by the way, which is Dictra, that's the one which been used for Google Map. If you have used Google Map in your phone or whatever it is to find direction, Dictra, that's the algorithm, that's the one which been used in Google Map. What's the difference between both of them? Both of them, they try to find out the shortest path. Yes, we agree on that. However, they use two different algorithms. The Bellman-Ford, which is usually you may heard about a protocol called RIP, which is the old protocol, and the latest one in the market recently, which is not recently, but the latest update, which is ERGP. Those one, both, they are using Bellman-Ford. What's exactly the concept of Bellman-Ford? The least number of hops. So, for example, I have here, I can go to G. Here, I need to go through 1 and 2. Okay, but here I want to go to 1, 2, 3. Which one I'm gonna take? I'm gonna take this one. In very basic fundamental concept. Is that involve actually more details? It is. And when you study the algorithm itself, it's really complex. But for you, as a business student, what you need to understand exactly that it works with the least number of hops or least number of routers. Alright, what about Dictra? Dictra is not. Dictra is involved in multi-metrics. It's involved with number of routers or number of hops, congestion, the speed of circuits, the bandwidth, the delay, the latency, many things, many factors, which is highly more sophisticated. Really, when you go over that, it does a lot of math in the middle. However, if you study that, how it works, you will find it has a lot of fun. One of the famous protocol as well, it's been used, the OSPF. And if you want to go, RIB was the eldest, then OSPF came after that, then ERGP. And sure, each one come with different version. That, for example, this is version 1, V2, and this is the same thing over here. So the latest right now, up to today, that's the ERGP. When you do routing between normal routers, we use what we call internal routing protocols, which is those protocols. The RIP, OSPF, ERGP. This is the most famous protocol in terms of routing. However, what is that exactly you call internal routing? What you mean by internal routing? Do we have external routing? Yes. The internal routing, which you can do within a network, a small network, sure, between a company to company, even a big company, it's still. But when we talk about service provider, something like Telstra or Verizon or you have hundreds of millions of customers and you have hundreds of thousands of routers, actually millions of routers. If you have done some research about how many router, for example, we have here in Australia or in US, you will have tens of millions in the United States and few millions here in Australia. So how the ISP provider manage those routers? Well, the main concept is go configure one by one. Okay, is that can be done? Yes, it used to be done. But is that the best option? Is not. When you configure one by one, that's wasting time and as well wasting resources. So what we do exactly, we have what we call it autonomous system. What is autonomous system exactly? You group bunch of routers. According to Cisco, they said up to, I think, 64 or something like that. You can increase the number of that in one group. However, nobody restrict to that number, and you can put whatever, either hundreds or 100 or hundreds, whatever the company would like to do. The concept is you put, instead of configuring one device per device, you group collection of routers. For example, let's say 100 routers, 200 routers at once, and you put them in an autonomous system. And that autonomous system, for example, call it AS100. And this one AS200. What is that? AS300. Like that. As here, this is 100, this is 200, this is 300, for example. Okay. Then what? Inside that AS, you can use the internal routing protocol, which is either RIP or OSPF or ERGP. This is the most famous ones. Okay, so inside this one, I can use either one of these. Yes, and actually, look at this. You can use over here, for example, RIP, and here OSPF, and here ERGP. That's true? Yes, it is. So what's the concept of that? If you configure that RIP, all routers inside that AS will use RIP. If you configure those ones as OSPF, all the routers inside that AS become OSPF. If you configure that as ERGP, all routers inside the AS will be ERGP. Okay, so this is ERGP, this is OSPF, this is RIP. How they talk to each other? Right now they speak like, it seems to be like they speak three different languages. Yes, what we have exactly, we have another protocol, external routing protocol or exterior routing protocol. What is that exactly? The BGP, Border Gateway Protocol. That protocol link between AS to AS. So if you want to link AS to AS, has to be BGP. Can we configure that on a router? No. It has, yes, in hypothetically, or because like whatever you configure here, you configure it's a router as well. But that router has some specific functionality which can work with interior and exterior as well at the same time. But the routing protocol itself as a BGP, can I configure those as an internal routing protocol and I put BGP? No. When you use BGP, you have to use between AS, that has to be AS, not normal router, or it is a router, but it's not a normal routing, internal routing. How to see something like that? Let me show you something like that. For example, this is an autonomous system. As you can see here, all those routers, as this is OSPF, That's very basic. All right, here we're using RIP, and over here, for example, we can OSPF or ERGP, whatever it is. Here it is. To link between that and that, you have to use BGP. To link between AS and AS, as you can see here, AS to AS, BGP. What about those router? RIP. You're using RIP here, which is RIP. You're using OSPF, all of them OSPF. So why we do that, by the way? For easier and faster management, which is totally away from your study for now. But why we using AS? AS is for easier and better and faster management. So let's go over those routing protocol, which internal routing protocol, as you can see. Very easy and very simple. Let's go over those ones very quick. The eldest one, which is the RIP protocol, which I believe that you may need that in your case study too. You can use that, by the way, if you want to. And by the way, that's the easiest one of configuration. However, that has disadvantage, which is it can work very well with low number of routers, which means that small networks. However, when you put it in a big network, it becomes really slow. Why is that? For the concept of broadcasting every 30 seconds. What is that exactly? Let me just show you. You have a router here, connect to router here, connect to router here, connect to router here. The same concept. Just to make sure we do understand that. Okay, let me put one more here. And by the way, you can build that in Packet Tracer as well, and you can see how it looks like. What exactly the periodically broadcast? You understand the concept of broadcast. Broadcast means you send a packet or message to everyone, to all. So I assume that we have to update each other, which I explained that before. Each router has a table, and this table has to be updated every 30 seconds, which means that every 30 seconds for me here as a router, I have to send that table here and here. Okay, and this one has to send his table here and here and here, like this, and here. And this one has to send it here and here and here and here and here and here, like this way. So imagine that you have, for example, right now, this is 3, 5, 6, 7, 8 routers only in a topology. You keep sending the full 8 to 8 tables every 30 seconds. What does that create? A lot of bandwidth, which means it creates a lot of traffic, and a lot of traffic means slower system. That's why when you have router that are RIP, if you use it with small numbers of routers, yes, it's okay, it's good, no problem. But the more you add router to, it become really slower, and we do not recommend you to use that type of protocol if you have a large number of router in a big jumbo network. So to go over that, which is you broadcast every 30 seconds, which means that every router, every node send its own table to everyone every 30 seconds. What to do exactly? They came up with another better version, which is OSPF. And this one, if you still remember, that's Dictra. So what is that exactly, OSPF? There is no broadcast as every 30 seconds. There is none broadcast like that. No. What happened exactly at the beginning of the building the table? What we do exactly? And by the way, that's happened when you use packet tracer and try to see that actually in visual. What exactly happening? In the first 60 second, 90 second, what we do exactly when you build a topology like that? We start talk to each other and we start exchanging the data with each other. And you can see the system is really busy within the first 60 to 90 seconds. We exchanging the data, you tell me what you're in your table, I tell you what in my table, I update my table as well, everything is good, yes. Now, the topology is stable, yes, done. Do I have to update you? No. Unless if something in the topology has been changed. Which means that, for example, if one of the link, for example, went down, now we have to exchange the data. But if the topology is okay, everything is okay. So in case, only in case something happened, is that's better? It is better. There is no broadcasting. We have less talk. In short, no broadcasting means there is no traffic much, and the system is much stable. So we prefer to use this one if you want to compare with RIP. Then we came back to the latest one, which is a ERGP. That's much more advanced. It's work both of them, ERGP and OSPF, they have a better function than RIP. They have some kind of security and ACL, which is access list. You can actually allow network based on IPs. And that's a different story from your study for now. But however, the ARGP and OSPF has a lot better option than RIP. The ARGP, that's developed by Cisco, and that's the latest and what's the most used. This one usually keep the routing table for the neighbor and use the information to make a decision. What does that mean exactly? You can say, it have a overlook view over the neighbors tables as well. You can see when you are in a router, you can see what's in the other router than your neighbors, and that's actually focus on the neighbors. By the way, the Billman Ford usually focus on the neighbors only. So you can keep the routing table for your neighbor, and you try to find out from your neighbor which is the best way to do. That ERGP use different type of metrics like bandwidth, capacity, delay, reliability. Oh, we have something else which is load balancing, and what we call it exactly quality of service, which is as well, you can implement that on ERGP. However, it's hard to implement that in RIP, for example. And that's the latest, and that's the one which is recommended. You will find that recommended for all Cisco products. We have another protocol called ICMP. We do not use that much in routing, but we use it for troubleshooting. That's really famous. If you actually using ping, which you will do, by the way, when you build your topology. If you build, for example, the topology in your case study, and you build something like that, and here you have a device, and here you have another device here. This is your PC1, PC2. You want to try to ping, which means that you want to ping here to see if you can talk to PC2. There is no pinging. There is no connection. So what you do exactly, we use that ping to track or trace if you have a connection or not. So I can ping and I can see the packet if it goes here. If it come back to me, that means there is a connection. If it didn't come back to me, there is no connection between PC1 and PC2. And that's usually reporting error. We use that in troubleshooting. The border gateway protocol, as I mentioned to you, we use this one only to link between autonomous system. And this one use Billman-Ford, the distance vector algorithm. This is a very basic concept. What's inside the router exactly? The router, as all the devices, has a motherboard or system board, whatever you call it. Inside that you will find the same thing: CPU, memory, ports, interfaces, and also it has an operating system, the iOS from Cisco. It contains very advanced command. You can execute this command. The main function for the router, as I told you, determine the best path and sending the data as well, transmitting the data. When you, if you get the chance to see an actual router, which we recommend, if it's not, just look at the back of the packet tracer or any image from Google, for example, and you will find it's look like this. This is the power, for example. Over here, this is the phone port, we call it like auxiliary or AUX, and this one usually connected to the modem. Why we connect to the modem? If you want to log in remotely here through the modem, the dial-up or whatever it is. And we're using access list, which is ACL, to connect to. What about that port? That's the console port. What is that console port? We use special cable called the console cable, light blue cable. If I want to configure that router, how to configure the router? Physical router, not packet tracer, for example. Physical router, we use a physical cable, light blue. We link it over here, and then I'll show you this one next. Here it is. That's the console cable. You can see that this is a console cable. How is that works? You can see, as you can see here, this is the port. We put it over here in the console, for example, like this, over here. And this one, you connect it to your laptop, for example, if you use the laptop, or you connect it to your desktop. Then we use a software. Sure, you put that setting as COM.1. This is the recommended speed. However, you can change that. And then after that, we use a software called PuTTY, and you start to configure the device right away. That's how it is. That's very basic. If you're using packet tracer, you will not need that, because you will actually click on the CLI right away and you will start configuring. Back again to over here. Okay, this is the console, which is the console port, which is we use it to configure devices, the router or switch or ASA, whatever it is. So what about those ones? That's the Ethernet connection, which is usually either fast Ethernet or gig Ethernet. In the old technology, the 841 model, that's fast Ethernet. In the 941, usually gig Ethernet, which is, you can see that gig 00, gig 01, and so on. And that's the Ethernet interface. Each one of these interfaces represent a different network. And that's to be a gateway. So what is that exactly? And by the way, those ones can be work with LAN, because those cables no more than 100 meter mostly. So if you want to use a LAN, that's the best option for that. What about if I want to use a WAN? So you need to use a cable, which is direct cable. What kind of cables? It has to be serial cable. That serial cable, this is how it look like, by the way. Serial 0, serial 1, that's how it look like. In packet tracer, you will find that empty, like this. This is an empty slot. So what we do exactly, we need to add a chase like that, which has, usually each chase has two different interfaces. This is an example of the network. I have explained something similar to that last lecture. However, very easy and very basic concept. If I ask you right now how many network we have over here, you need to say, okay, this is 1, this is 2, this is 3. Okay, is that it? No. We have 4, 5, and 6. That's how it is. That's what it should be, like that. So as you can see over here, net A, B, C, and this is between the routers. If you can see here what's between the router, we use the /30. Last week when we covered the subnetting, I told you you will need here a minimum of 4 IP addresses. You need 2 physical for this one and this one, for example. You need to give IP here and IP here. However, we still need another 2. One for the network ID, which you can see here, and one for broadcast. So for example, over here, they put 192.168.20.4. Okay, let's take it from the bottom so you maybe understand better. 192.168.20.0. Alright, so the network ID is 0. So what I have, and this is /30. /30 means I have only 4 IPs only. This is the network ID. Okay, so I'm gonna take 1, 2, number 3 will be the broadcast. That's it. So over here I'm gonna put 1 and 2. That's how it is. Yes, so for example, this is gonna be 192.168.21.22. That's how it is. Yes. Number 3, can I take number 3? You can't, because that's a broadcast for that network. So the next network, what it can take? Number 4. And by the way, usually the network ID has to be an even number. The network ID got to be an even number. Okay, so this is the network ID for 4. Okay, so I can put here 5. I can put here 6, and then the broadcast will be number 7. So 5, 6, and 7 will be the broadcast. So this one reserve, this one reserve as network ID. This is the IP I can put. That's why you can see here number 5, number 6. We can put 5 here, 6 here, or 5 here, 6 here. Doesn't matter. And the last one, which is number 8, 20.8. This is the network ID. Okay, I can take 9, I can take 10 as an IP. For example, I can put 9 here, 10 here, or the other way around. Doesn't matter for us. And then 11 as broadcast. And this one will not use in configuration. So can we do that? Yes, we can do that very easy. How to do that? We just go to the CLI, and inside the CLI we will find something like that. If you use packet tracer, you will not use that in your case. However, that we use this one in actual physical router if you get the chance to do so. In packet tracer or in the normal configuration, when you reboot the device or boot up the device, you will come up with something like that. It ends up with continue with configuration dialog. Yes or no? Say no. Because if you said yes, it's gonna take you step by step for long type of configuration. So you need to answer no. After that, this is the packet tracer version. After that, we have here few commands, very famous command, and this is what we call it like basic configuration. Here, which we cover as well, what we do exactly over here, you start with, this is the privilege mode. The privilege mode over here, or the enable mode in short. So when you see something like that, that's you are in the enable mode or privilege mode. The most, if you want to see any command, by the way, here, if you want to see any type of command here, just type question mark and hit enter. It will give you a list of the command you can configure it in that level or in that mode. That's one of the problem in Cisco OS, but you're gonna used to it after few days. After that, you can over here, you go from here to the configuration mode or the execution mode. You type config T over here. It's gonna take you to the, for example, when you see the hash, then you type, for example, router, the host name, for example, this is the host name. If you want to change any type of configuration on the router. This one, by the way, you can over here, the hash mode, you can put over here what we call show. For example, run, copy, running config to startup config. For example, you have here, if you want to save something, for example, if you want to erase whatever inside, if you want to reload, it's over here in that mode. If you go for the configuration mode, for example, the configuration mode here, if you want to type config T, it takes you to the configuration mode, which is this one. When you see config, you can change up here, you start changing configuration. Put, for example, host name. What is that command? No IP domain lookup, to understand that. One of the problem with, if you mistyping any command, what's gonna happen exactly? The system, the operating system will start, for example, I start type XYZ. What's the operating system will do? Will start looking for the XYZ. No problem with that. There is a problem. As far as the operating system start looking for the DNZ, that command line will freeze. For how long? Around 90 seconds. So your command line will freeze around 90 seconds. You will not be able to do anything. Totally. To do that, to avoid that, what to do exactly? Type that command. No IP domain lookup, which means that if I have disabled the domain name lookup, so if I mistype anything, it's gonna give you error and you keep going right away, no problem. So here, if you want to put some kind of password, we can put password in the enable mode. For example, if you try to type enable here, it will ask you for password. And in the console as well, the console itself, we can put line con, command called line con. If you want to put a password in the console as well, yes, to secure the system. However, if you want even the enable as well, which we reckon as well, you need to put a password. Line con, which is 0, as you can see over here, I can put password here, by the way. So if I try to use the console, you have to put password before you call the console. What is login synchronous? Okay, when you type something, for example, if I type interface fast 00 no shut, it will come up automatically and will interrupt my configuration. Because I'm typing, you execute command. That command has to be executed, then you type the next one. Do you want that when you're typing? Is not. When you type in real work, you type very quick and very fast, and you execute plenty of command in seconds. So what you do exactly, we don't want interruption. So when I execute any command, like, do not interrupt me. Do not interrupt the command line. That's the command with login synchronous. If you want to configure any interface, very basic, type under the configuration. You have to be under the configuration mode. Type the interface int or interface, whatever it is. Type the interface name. If it's fast 00 or serial 00 or serial 01, for example, as you can see over here, we configure this one. That's this interface fast 00. Okay, so I'm here right now, fast 00. and as you can see here, I become inside the interface. Do I need the description? No, by the way, this one is not required. So you can put it yes. If you don't worry about that. But to the most important for us, those two commands. You need to put an IP address. This is the IP address, and you need to put the subnet mask. So this is 192.168.10.1, which I reckoned to you before. We prefer to have the first IP in the network or the subnetwork as the gateway. Up to here, if you type this one, you configure the interface, but you do not put it up. Put it up means it's still shut down. We need to put that interface like you can see that this is red, it's still red. So if you want to make it as a green and become active, you need to put the no shut or no shutdown. Either one is okay for us. The same concept over here, you go inside the serial 011, you put the interface, the IP address, which is 9. And here, one of the things which I want to show you, why this one, as you can see over here, this is 30. Why this one 255, 255, 255, 252? If you want to know how we got this one, put 30 ones and separate them . 1, 2, 3, 4, 5, 6, 0, 0. This one will give you 255, 255, 255, and as you can see over here from the binary, this one will give you 252. The same concept over here. What exactly that? You put the same thing. One thing I just want to show you, because what is the clock rate? As you can see here, by the way, there is no clock in here. There is in packet tracer two type of link like that. One of them with clock, one of them without clock. You will see a clock in one of them without clock. What is that exactly? For some applied for DCE connection. If you want to configure a DCE, which is away from study totally, from one side to another side. If two sides they talk to each other, and you want to restrict the rate, how fast that device can talk to that device, you need to put a clock rate, what we call clock rate. Is that required for your case study 2, for example? No. However, it's good to remember something like that. The RP and RC configuration, as you can see over here, you just configure the interfaces. You need to configure this one, then you configure the link between. The most important, what you do exactly, you need to put the IPs, allocating IPs. If you allocate the IPs correctly, you will configure that later on correctly. Most of the configuration or the errors between routers usually come from not actually allocating correct IPs. This is an example of the basic RIP configuration. However, one of the things here which we actually don't recommend to do, putting a layer 2 device, which is a switch, in the top of layer 3 device. This is layer 3 device. We do not prefer to have something like that. This is 2950. If this one 3950 or 60, which is layer 3, will be okay. But to put a layer 2 switch in the top of layer 3 device, we don't prefer to do that. However, the concept here is very clear. Don't worry about that. As you can see here, the concept of that is, this is the PC.2.2. This is another network 1.2. Sure, this 1.1.1 from without seeing. This one, the gateway as well, 2.1. The first IP in the whole network. This is the second IP. This is the first IP in the network. This is the second IP. Now I want those ones without routing, without RIP protocol or OSPF or ERGP. Those devices will not be able to talk. You will be able to reach here. You will be able to reach up to here to ping. But can you ping here, for example? You will not be able to do that. So what we do exactly, you need to have a RIP as a protocol in both devices here. How to do that? Here it is. Very basic, by the way, if you want to configure RIP. Very basic and very fundamental. If you, for example, this is router number, this is 2.2 or that's 2.0 and that's 1.0. Let me show you. This is here, and this is the 192.168.1.0, and this one 192.168.2.0, and this one, for example, 3.3.3.0. That's it. Or if you want to make that in much easier, here it is 1.1.1.0, 2.2.2.0. I think that's much easier. That network is 1, this network is 2, this network between is 3. How to configure the RIP usually? Very basic and very fundamental. Router, type the command router RIP and add that one version 2 at the bottom. Then start list the network IDs which link to that router. For example, what link to that router? Okay, I'm gonna type network. What's network? 1.1.1.0. What else? 3 network 3.3.3.0. Okay, done. I'm gonna come over here. What's the network link over here? The same concept. Router RIP version 2. The network, list the network, all the network, whatever the network, even if you have here 4 or 5 network, list them. But since we have 2 only here and here, I'm gonna put like that. What's the network over here? 2.2.2.0, 3.3.3.0. As you can see here, there is something coming between both of them, which makes them, they will talk. What is that? 3.3. You have 3 here and you have 3 here. Those ones will talk to each other. So the one will be able to talk to 2 through the middle one. That's it. That's the whole concept. And you can see over here. Over here we will put 1.0 and we will put 3.0. 1.0, 3.0, 2.0, 3.0. So what's the common between both of them? 3.0. So that network will make those 1 and 2 talk to each other. It will work between both of them. How do you know if you have a RIP or non-RIP, or if you have actual connection and it's work or not? Type the command show IP route, which is very basic over here, by the way. Show IP route. When you show IP route, you will find some kind of acronyms. If you see something, for example, C, which means directly connected. R means RIP. If you see the R, that means your configuration exists already, and you can see over here 192.168.2.0. you can go via 192.3.2 to the fast Ethernet and over here, which means that you can see that exactly that I have a RIP here, which is routing protocol RIP. Up to here, this is the most we need to cover, and I believe that even some of these is actually beyond the business model in your case. Try to go over that exercise. Try to understand the difference between routing protocol and the static routing protocol and dynamic routing protocol. Try to use that slide, which is how the routing table packets goes from one device to another device. Go over the materials, try to understand as much as you can. If you have any issue, come back to me within the lecture time and the lab time. I'll be more than happy to explain more. During the lab, I will show you an actual demo on Packet Tracer. All the best and have a good one.